Welcome to Economics Trainer. This video was made to help you strengthen your skills in microeconomics. Here we have a sample question, care of brighttutoring.ca. It's the kind of question you'd expect to see on a test in a second-year microeconomics class. Let's work through it together. So here's the question. Suppose we have a consumer with a Cobb-Douglas utility function of u equals x to the 0.5, y to the 0.5, and marginal utilities of mux equals 0.5, x to the negative 0.5, y to the 0.5, and the marginal utility of y will be 0.5, x to the 0.5, y to the negative 0.5. The consumer will have $32 to spend on goods X and Y. And then what we have to figure out in these questions is in the first question, we have to find the consumer's optimal bundle when the price of X is 2 and the price of Y is 2. And then similarly in the second question, we have to find the optimal bundle when the price of X is going to increase to $8 and the price of Y remains the same at 2. Once we have those two optimal bundles figured out, and we have the total effect, what we have to do is decompose it and find the values of the income and substitution effects in the next question using the decomposition bundle technique, and then we can figure that out for both good X and good Y. So let's start off here with the first question and find the optimal bundle. So for question 1 here, let's use the tangency condition, mux over muy is px over py. We can plug in those equations. So let's see, mux was 0.5, x to the negative 0.5, y to the 0.5, and the price of x was 2. And then at the bottom, let's see, mux, that was 0.5, x to the 0.5, y to the negative 0.5. And over here, the price of y was also equal to 2. So let's see here, okay, the 0.5s, those will cancel. And then for x and y, we just have to deal with the exponents here. So if we subtract the exponents on x, we're going to get negative 1. So we'll have x on the bottom. And then for y, we'll have 1/2 minus 1/2. So it'll be plus. So we get y on the top. And then what we have here is 2 over 2. Okay, that just equals 1. So here we're going to get y equals x. That'll be our first equation. And let's take that and let's plug that in to the next equation we're going to use, which is a budget constraint, which is income equals spending. So income I equals pxx, we're spending on x, and then spending on y. So the key thing here is we know y equals x from the tangency condition, so we can plug that in as we go. So the income is 32. We know the prices are 2 each. And then when we hit the y here, we can plug in for the x and say that'll be okay, that's going to be an x as well. And then what we have here is 32 is 4x. So that means the x star for this first one, let's call this x star A, is going to be 8. And then going back here for y, you say, okay, well, y is equal to the same, so we're going to have y star A is also equal to 8. So that's going to be the first question here. So going back to this optimal bundle, so at these nice low prices, we're going to have 8 for x and 8 for y. And we can do the same thing for the second question here. All we have to do is just change the price of x to 8 instead of having 2. So we go to the second part of the question over here. We say, okay, we figured out part A here. Let's go to question 2. And then let's see here. For this one, we do the same tangency condition. And so the great part over here is on the left-hand side, nothing changes. So we're still going to have y over x on this side. And then what changes is on the right-hand side, now we have px, the new one. So that's going to be 8 over 2. So we get with y, see half of 8 is 4, so we get 4x. And then we're going to take that and let's plug that back into the budget constraint. It'll be the same on this side. 32 stays the same. And then px is going to be 8. And then plus 2. And then here when we sub in, we're going to have to sub in 4x. So let's see here. We're going to have 8 plus 8 is 16x. So the new x of this bundle, we'll call this x star c. That's going to be 2. And then going back here to the y, we can see, plug it back in, say, okay, well, y is going to be 4 times the x value. So the y star at this optimal bundle is going to be 4 times 2, which is 8. We can call that bundle C. So we're going back to the question here. So you can see here when the price of x increases, they were buying 8 before, now this goes down to 2. And then for y, that stays the same at 8. So that's how we do those first two questions. And then once we have that figured out, we have to use that to complete the table here and figure out the income and substitution effects. So the best way to find those effects is to draw it out in a graph here. Let's draw out our optimal bundles here. And then we can figure out the effects here. So we have good x and good y. And then initially, let's draw out the budget constraint here. So this was income over the price of x, which was initially 32 over 2, so that'd be 16. Same as up here for y. And then on this new one over here, we can see, okay, with this new budget constraint here, this one, we're going to have the price of x, it's going to increase to 8, so it'll be 32 divided by 8, so this point here is going to move into 4. And then we'll have 16 will be the same for y, because its price stays the same. So there's the new budget constraints, and then we can see what happens to the optimal bundles here. If we look at those, we can see for this one we had 8 and 8, so it's about halfway here. So that'll be bundle A. And then we can see over here with bundle C, for this one here, it's 2 and 8, so we're going to have that over here. So what happens here is going from our total effect is going from A to C. What we have to figure out is an optimal bundle between the two. So if we take this budget constraint and move it up, we can use the decomposition bundle technique and say, okay, what bundle do we get up here? This one in blue here. This will be our decomposition bundle here. So this one decomposes the effects, because we'll see here when we throw in the indifference curves, this one will have the same utility as here, which will be UA, and then down here, this will be the new utility. And then you can see the effects here going between the two. So A to B here, this is going to be our substitution effect. So we're sliding along the indifference curve. And then going from B to C here, that's going to be our income effect. So we can draw this out here. We say, okay, so we have A to B to C. And then the order here, you can see it's going to be substitution effect first, and then the income effect. So we just have to calculate the distance between all these numbers here and get this bundle here, and it can calculate all these effects. So let's go over here in the blue. Let's figure out this decomposition bundle here. So the tricky part here is the decomposition bundle has the same indifference curve here, so we can use the indifference curve of A, and then it's going to have the same slope as the tangency condition over here. So we can use the tangency condition from point C here, which we have over here. So we can say, okay, tangency condition from this green line here, it's the same slope, so we're going to have y equals 4x. And then over here for the indifference curve, this is what we have to figure out for the decomposition. We have to find that number. So if we look at u bar A, let's calculate it here. We can go back to the utility curve. It was just the square root of each number. So if we look at A, we had 8 to the 0.5, 8 to the 0.5. So we just have two square roots, 8. That's going to be 8. So what that does is it gives us the equation for the indifference curve. 8 equals x to the 0.5, y to the 0.5. Or we could square both sides and say, well, 64 is x times y. And that's going to give us nice useful equations here. And we can substitute it that way. So that's how you do the decomposition bundle, is by using this indifference curve. That's the key thing between doing the decomposition bundle here and the optimal bundles here, where it's always tangency condition budget constraint. Here it is tangency condition indifference curve. That's the key difference here, finding the point in the blue. So let's plug in these two equations into each other. See, wherever we see a y, we're going to have a 4x. So we just do 64 is x times y, which is 4x. So let's see, we have 64 equals 4x squared. See, 64 divided by 4, let's see, if we divide it by 2, it's 32, and do it again, we get 16 is x squared. So here we're going to have your x star b for the decomposition bundle, the square root of 4, from the 16. So you have that there, and then for the y, what we have is we're going to say, okay, it's 4 times that, so the y star b is 4 times 4, which is 16. And so that's going to give you the bundle B. So you can see, okay, for B here, if we go over here, say, okay, that one's 16. So we have B, and then this one here, that point there is going to go all the way down to the 4. So it's kind of drawn freehand here, so it doesn't connect perfectly, but when you do draw it perfectly, you can get the numbers to match up, but that's how we can visualize it here. So now we can figure out all these effects going back to here. I figure out the table for the substitution effect. So all we have to do is just go backwards here and say, okay, for the substitution effect for x, that's going to be x star b minus x star a. So we say, okay, well, our x star b is over here. That's 4 minus the x star a, which is up here, which is 8. And so that's going to be minus 4. And then for the income effect, we do the same thing. For the substitution effect for y, let's do the same thing, because it's just the similar numbers, but we just do it for y instead here. So let's get that done. So y star a. So let's see, okay, y star b is 16 over there. And y star a is 8. So we're going to have 8. And then for the income effects, we do the same thing. We just look at it and say, okay, the income effect is this jump here, or we're going from B to C. So we go backwards in the math here. We say, okay, this is x star C minus x star b, which is where we started. So let's see, okay, x star c at the end, that's 2. And then minus x star b. Let's go over here, that was 4. So 2 minus 4, it's going to be minus 2. And then we do the same thing for y. So let's see, it's going to be y star c minus y star b. So what do we have here? We have y star b, which is 16. And then if we go up to the y star c, up here in green, there we go, we have 8. So 8 minus 16 is minus 8. So here we have all our effects here figured out. So let's go back. We say, okay, for this x, we have the income effect of minus 2. And then its substitution effect is going to be minus 4. Let's see, minus 6 here. Oh, minus 4. And then for y, let's see, we have minus 8 and 8. And that's how you do that question. This video is brought to you by people who like, share, and subscribe to this channel. You can also support my work by buying me a coffee.